This is Trigonometry Part 4. And there's going to be a lot of parts to trigonometry, even though trigonometry is not that big of a subject, but I'm going to give you some better details than what most other people will, simply for the fact that they just don't feel that they should bother with some of those details. And I'm sorry that some of these people feel that way, but I feel you need them. Okay, now let's go back to this for a second. We have a triangle, and it's right angled, just like this. Now, in my previous video, I made one tiny mistake, and I'm surprised that some of you people didn't catch it. Here we had 80 videos that I made about Euclid's proofs, and you guys didn't catch my mistake. So, let's go over what is not a mistake, and then we'll go into what was. And we'll correct that mistake in this video. First of all, I told you that this was a right angle triangle, which is true. And there's the right angle right there. And I told you that this angle right here is acute because this is a right angle triangle. Right angle triangles always have an acute angle. Guaranteed. Okay? Now, I said that the side opposite of the right angle is called the hypotenuse, and that is true. Okay? And then I said that when you're dealing with an acute angle like this, which I labeled as theta, okay, you're going to have a side that's adjacent to the hypotenuse and a side that's opposite of this angle. Okay, we're talking about this angle right here. So we have a side adjacent, which means that it's one of the two rays of an acute angle like this, and then you're going to have a line here that's going to be opposite of this angle. Okay, so side opposite, side adjacent. All that is true. Now, the only thing is, and I'm surprised none of you caught this, if you have a right angle in a triangle, that's 90 degrees. Now, I declared in a Euclid proof a long time ago that triangles have three angles, and the sum of those three angles is 180 degrees. Now, if you subtract 90 degrees from 180 degrees, you get another 90 degrees. Now, you split that up in between two angles, and you'll find that you will not have just one, but you will have two acute angles in a right angle triangle. Okay? And that's the mistake I made. I was saying that this angle was obtuse, and it's not. It's acute. Both of these are acute angles. Alright? So, what are these? Okay? Now, I told you that this here is the Greek letter theta, and it is used to label acute angles in a right angle triangle when you're trying to deal with trigonometry. But let's say you wanted to find sine, cosine, tangent, secant, cosecant, and cotangent of this angle up here rather than this angle down here. Alright, well, you don't want to make references to this angle right here when you're trying to find sine, cosine, tangent, and so on and so forth up here. Instead, you want to label this a different angle. So they came up with these Greek letters. And you'll have the Greek letter alpha, beta, gamma, and phi. This one here is phi. This one here is theta. So when we're talking about the sine, cosine, and tangent of the Greek letter theta here, then we're talking about this angle right here. If we want to find the sine, cosine, and tangent of this angle right here, we'd be talking about the sine, cosine, and tangent of angle phi. This is angle theta, this is angle phi. And that way we can distinguish between angle theta and angle phi. And we can find the sine, cosine, tangent, cosecant, secant, and cotangent of both of these angles. And we can make them down in a mathematical list. We can have all six sine, cosine, whatever here of angle theta, and sine, cosine, whatever over here for angle phi. So basically, these are going to be labels for angles in a right angle triangle. Okay? So, I'm going to show you this one more time. You can label angles in this kind of a triangle alpha, beta, gamma, phi, or even theta. Okay? And based on what angle you're referring to, you could get sine, cosine, tangent, secant, cosecant, and cotangent. And I will go into further discussions of this in a future video. But keep in mind that the two rays of an angle, remember, angles always have two rays. Here's angle theta here. It has a ray 1 here and a ray 2 here. This happens to be the hypotenuse, and this happens to be the side adjacent. Okay? So, angle theta here has two rays, and they are straight lines. But keep in mind that according to Euclid Book 3, you can have one ray that's a straight line and another ray that is a curve. And if you don't believe me, you can go back to Euclid Book 3, proposition number 18, and see for yourself. That's right, folks. Not all angles have totally straight lines. Sometimes they'll have one ray that's a straight line and one ray that's a curve. And this becomes very important because we're going to graph functions, and we're going to make tangents to those functions. And the tangent line is going to be straight, but the function itself is going to be a curvy line, like a parabola or a hyperbola. And I haven't covered either one of those yet, but I will. And when I do, you'll understand what I'm talking about. I already covered tangent to the curve in a previous video, so you should be watching that so you know what I'm talking about here. Remember, when we're figuring out the trigonometric tangent, we're figuring out tangent to the line or tangent to the curve. And if you don't know what a tangent is, you need to go back to a previous video that I made that discussed it. Alright, I will tell you more in a future video, so stay tuned.